All right, so previously we measured a circuit in simulation using the probes, and we got 3 different inputs for different voltage dividers for each probe. So now in our oscilloscope, we need to choose which voltage divider we want to use. So in order to do that, we first need to import those voltage signals that we got from the previous file into this one. So to do that, we double click here, and we're going to select a piecewise function, and here you can import by opening up a file. So in the previous video, we made separate text files for each probe. So here we just need to load each of them back in. So this is the 1 to 5 for probe 1. I load that in. You can test it to see how it looks like. It looks like that, so that's good. All right. So now we go to the next one, which is the 1 to 10 for probe 1. I just need to open it up here. All right, good to go. Do the same thing over here, 1 to 20. Over here, probe 1, 1 to 20. All right, now we have to do the same thing for probe 2. So probe 2 is down here. This is 1 to 5 for probe 2. So probe 2, 1 to 5. Looks like that. Probe 2, 1 to 10. All right. And probe 2, 1 to 20. All right. So now each of these, if you see these little junctions, will be inputted into the corresponding junction right here. So this 1 to 1 will appear here, this 1 to 2 will appear right here, and this 1 to 3 will appear right here. Similarly, this 2, 1 will appear here, this 2, 2 will appear here, and this 2, 3 will appear here. So now this yellow block represents a analog multiplexer. So the analog multiplexer will let one of the signals through. And the signal that it lets through is the voltage divider ratio that we'll be using for the rest of our system. So since our original voltage was 20, I feel like a good voltage divider ratio would be the 1 to 10. That way the maximum voltage would be 2. So in order to do that, I need to choose the 1 to 10 for channel 1 and channel 2. So the 1 to 10 is this N22 and N12. So it's this input right here. So I need to select this value right here. So in order to choose which value to select from, you need to control it with these A lines. These A lines represent the select lines. So over here I have some switches that will help me control the voltage of those select lines. So V plus, it will be a positive voltage, which will be a 1, and V minus will be a negative voltage, which will be read as a 0. Now if I want to get this input right here, I need to look at the S numbers. So even though this says S1, this is equivalent to if all the select lines were zeros. This is 0, 0, 0. This is 0, 0, 1. This is 0, 1, 0. This is 0, 1, 1. 1, 0, 0. 1, 0, 1. 1, 1, 0. And 1, 1, 1. So in order to pick this input, I can choose either 0, 1, 0 or 0, 1, 1. So over here I have 0, 1, and 0. So that will give me this input right here, which is the voltage divider ratio that I want. Notice how there's only one set of switches that controls both probe muxes. And that's because the voltage ratio for both channels must be the same. So they're both controlled by the same set of switches. So if I set this one to 1 to 10, then this one will also be set to 1 to 10. So with this setup right here, I can go ahead and run the transient again. And I'm going to run it for the same 1 millisecond using those imported sine wave or signals. And I should, at the end of the multiplexer, at this output, I should get the desired voltage divider ratio, which is 1 to 10. So I should be expecting an amplitude of about 2. So while that's running, we can talk about a few other things on the chip. The chip also has an enable, which I've set to always be high, so the chip is always active. And it has just ground and V plus and V minus right here that you see that I've set up with the correct pins. And this entire system, again, is running this plus minus 12 volts. So all right, that's done here. So we see that we've only extracted the 1 to 10 now because there's only the signals that go up to about 2. And all the 1 to 5 and the 1 to 20 are no longer present because the multiplexer has selected the 1 to 10. So from here, once this is finished, obviously, this is all for this circuit. So we'll need to export this out again and import it into the next circuit. So to do that, we're going to do the same thing as last time. We're going to go ahead and export it as text, and I'm going to save this as voltage select. So now that I've saved this, we can open it up back in Excel. So here we are in Excel. I'm going to open it back up. So let's see, where's the voltage select? I open it up. Again, this is tab delimited, so with the delimiter set to tab, you should be able to get it back out. Now, just like before, we'll need to split this up into 2 separate files for each of these. But another thing I want to note is how many samples are now in this file. So if we scroll down to the bottom, we see that we now have 3,959 samples approximately. And before, when we did the first input, the number of samples was around 300 and something. So we got approximately 10 times as many samples on the output as we did from the input. And this can prove to be dangerous for our simulation, because if the number of input samples keeps growing larger and larger, the simulation time will take too long, and the circuit and the program will probably crash it or run into memory issues if we run too many samples in. So we need to reduce the number of samples from the output to be approximately the same as the input. So that means we need to take every 10th sample to divide the number of samples by 10. That way we can have a relatively the same number of samples coming out as we had coming in. So in order to do that, I've developed a second macro, and this macro is called filter samples. So if I open up the code for filter samples really quick. So split samples was just splitting them into separate files, but filtering them splits them into separate files, but also includes this modulo counter. And this modulus counter is set to 10, and what that does is it'll extract every 10th sample. So if I go ahead and run this macro, this filter macro, and I run it, it'll split them up again. But if we look at how many samples we have, we're back down to about 300 and something, 397 again. So we have now reduced the number of samples back to approximately about the same as the input. And this is important to make sure that our simulation time is reasonable. So with these, now I just have to save them back as tab delimited text files, and they'll be ready to be imported into the next part of our system. So here's one, and this is for voltage probe 1, and this is for voltage probe 2, as I save it as a text tab delimited. All right, and so that's the original one. So that's all for this part. So once we've selected the voltage divider ratio, we'll need to now do a couple of other things with it, which I'll cover in the next video.